Let us see how to find the generator polynomial for BCH code. So BCH code is a cyclic code with multiple error correcting capability. So we have already seen the cyclic code. So the generation of the BCH code is same as cyclic code. The difference is in finding the generator polynomial. You know there are two methods of finding the cyclic code. One is non-systematic method and another is a systematic method where we use the division method. So the same method is applied for BCH code, but the thing is that you have to find the generator polynomial differently in BCH code. So that we are going to see here. So they have given you n equal to 7, which is block length, or which is also called code word length. TC is equal to 1 comma 2. So in a cyclic code, um, we fix TC, that is equal to 1 only. So in a BCH code, you have to check whether how much errors it can correct. Or first specification is number of errors to be corrected. So TC is 1 or 2. So let us first take n equal to 7 and TC equal to 1. So the first step is to find the m. So what is this m? That decides your Galois field. Uh, Galois field, we have already seen extension field, how to obtain the extension field from the base field. So there we know that we have a Galois field, for example. So Galois field 2 raised to m, we say. So we have seen that we obtain Galois field 8 from Galois field 2. So there Galois field 8 can be expressed as 2 raised to 3. So this is your m. So Galois field 16 is expressed as Galois field 2 raised to 4. This is your m. So here m you have to find. So for that the equation is n plus 1. This n plus 1 is equal to 2 raised to m. So 7 plus 1 is 2 raised to m. That means 8 is equal to 2 raised to m. So m equal to 3. So that means you are using Galois field 8, which is an extension field obtained from Galois field 2. That means coefficients are either 0 or 1. And we have obtained the elements 0 to 7. So that basic you should know, and we have already done many videos on these basics. So m we got. Then after that n minus k is equal to mtc. This is the new equation in BCH code. N minus k is equal to mtc. So n minus k is equal to 3 into tc is equal to 1. So 7 minus k is equal to 3. So 7 minus 3 is equal to k. So k equal to 4. So we got the specification for the code, that n equal to 7, that is number of code word bits are 7, number of message bits are 4. That means it takes the message bits equal to number of message bits equal to 4. M is equal to 3, that means we are using the extension field Galois field 8, that is Galois field 2 raised to 3. TC is equal to 1. Now how to obtain GX? So GX has now GX, this is important, GX has alpha, alpha square, alpha cube. Likewise you have to go up to alpha raised to 2 TC and their conjugates as roots. Okay, so you know this that what are the conjugates, how minimal polynomials are formed from the conjugates. We have already done many videos on this. We have done the videos with Galois field 8 as well as Galois field 16. So this sentence is important, that GX has alpha, alpha square, alpha cube up to alpha raised to 2 TC and their conjugates as roots. So what is GX? GX is LCM. You will come to know why LCM is taken. So LCM of minimal polynomial correspond. Now in our case, what is alpha 2 TC? In our case, alpha 2 TC is alpha 2 into TC is equal to 1. So alpha square is alpha 2 TC. That means we have to take minimal polynomial because why we are taking minimal polynomial, because you know that we have already found the minimal polynomials regarding this in the basics of Galois field. So gx has these roots, that means minimal polynomial also has these roots. So you can utilize minimal polynomials corresponding to that root for finding gx. That's why we are using minimal polynomial. So minimal polynomial corresponding to alpha, then minimal polynomial corresponding to alpha square. Only these two. Why? Because 2tc. 2tc is equal to 2 into 1. That is tc is 1. So alpha square only. So this needs your again basics. So we have seen this table. If primitive polynomial is x cube plus x plus 1, so in the exam they will give you what is the primitive polynomial. So we have taken it as x cube plus x plus 1. We have seen this equation with a primitive polynomial x cube plus x plus 1 as well as x cube plus x square plus 1. There we have seen that alpha square alpha raised to 4 has minimal polynomial x cube plus x plus 1, because alpha square alpha raised to 4 are conjugates. Then alpha cube alpha 5 alpha raised to 6 are conjugates. Their minimal polynomial is x cube plus x square plus 1. So what is our gx? Gx is LCM of minimal polynomial of alpha and minimal polynomial of alpha square. Now what is minimal polynomial of alpha? That is x cube plus x plus 1. What is minimal polynomial of alpha square? X cube plus x plus 1. That's why you have to take LCM. So LCM of x cube plus x plus 1 comma x cube plus x plus 1 is x cube plus x plus 1. So that is your gx. So this is must that you should you should be perfect in Galois field, root finding and minimal polynomials and conjugates. Let us take second case, that n equal to 7, tc equal to 2. So n plus 1 equal to 2 raised to m. So 8 is equal to 2 raised to m is equal to 3. So you are going to use Galois field 8. Why this m is important? Then only you can use this table. Because if m equal to 4, then you have to use the Galois field 16, and there that table is different. So m equal to 3. So n minus k is equal to mtc. N minus k is equal to mtc. So 7 minus k is equal to m, 3, tc is equal to 2, 6. So 7 minus 6 is equal to k is equal to 1. So this is 7, 1 BCH code. Now alpha 2 tc you have to find. Alpha 2 tc is alpha 2 into 2, that is alpha 4. So LCM of minimal polynomial of alpha, you have to go up to 4. Alpha square, alpha cube, alpha raised to 4. So LCM of what is minimal polynomial of alpha? That is x cube plus x plus 1. What is minimal polynomial of alpha square? X cube plus x plus 1. Alpha cube, x cube plus x square plus 1. Alpha raised to 4, x cube plus x plus 1. So these 4 are written here. Now you have to take the LCM. That's why this x cube plus x plus 1, x cube plus x plus 1 and x cube plus x plus 1, among them you are taking only one, that is x cube plus x plus 1. And x cube plus x square plus 1 is 1 only, so you have taken that. Now you have to multiply this. So the multiplication is, gx is, you know the multiplication. First you have to multiply with x cube to all this, that is x6, x5 plus x cube. X with all this, so x raised to 4 plus x raised to cube plus x. Then 1 with all this, so x cube plus x square plus 1. Now this is base field is Galois field 2, that means coefficients are 0 or 1. So x cube gets cancelled out because 1 plus 1 is 0. Then x6, 5, 4, 3, 2, x1. So this is your generator polynomial. It has degree 6. Gx has degree mtc, maximum degree mtc. M is here 3, tc is 2, so 3 into 2 is 6. So this is for the generator polynomial in BCH code.